Good morning, my dear students of second secondary. Today's lesson is called the arithmetic sequence, and this lesson is given for both sections, arts section and scientific section. Let's start. In the arithmetic sequence 12, 14, 16, find the value of its eighth term. Take care. This sequence is an increasing sequence where A equals 12 and the difference equals Tn plus 1 minus Tn, and the difference here equals 14 minus 12 equals 2. Then the value of the eighth term. Here the general term rule of the arithmetic sequence is Tn equals A plus n minus 1 multiplied by d. Eighth term T8 equals A plus 8 minus 1, which equals 7 times d. Here, the eighth term A equals 12 plus 7 multiplied by the difference, which equals 2, and here the value equals 26. Then T8 equals 26. The order of the term whose value is 102. In this sequence, 12, 14, and 16, it is required to find the term 12, 14, 16. It is required to find the order of the term whose value is 102. Here, Tn equals A plus n minus 1 multiplied by d. The value of the term is 102. Here A equals 12, n minus 1 is undefined value till now. We don't know the value of n, the order of the term, and the difference of this sequence equals 2. I'll transfer 12 to the right hand side, therefore 90 equals n minus 1 multiplied by 2. I'll divide it by 2. يبقى n minus 1 equals 45, then n equals 45 plus 1 equals 46. Therefore, the term whose order is 46, its value equals 102. The order of the term 102 is 46. Another example, in the arithmetic sequence 63, 59, 55 till negative 133, find the value of the seventh term. I'll try another color. In this sequence is an arithmetic sequence. The sequence is an arithmetic sequence where A equals 63 and the last term of this sequence equals negative 133. Take care. This sequence is called finite sequence. It's called a finite sequence because its first term and its last term is defined. Then Tn equals A plus n minus 1 multiplied by d. The seventh term equals A plus 6d. Then T7, A is 63, 6 multiplied by the difference, which equals 59, minus 63 equals negative 4. In this sequence, I'll find the difference by subtracting Tn from Tn plus 1. I'll choose any consecutive terms and I'll subtract the older one from the new one. Then the difference equals negative 4. 59 minus 63 equals negative 4. Since the difference is a negative number, therefore this sequence is a decreasing sequence. Then T7 equals 63 plus 6 multiplied by negative 4, and this value by using the calculator equals 63 plus 6 multiplied by negative 4, this value equals 39. This sequence is a finite sequence. This sequence is a decreasing sequence because the difference is a negative number. The number of the sequence terms. Here the sequence 63, 59 till negative 133, 63, 59 till negative 133. It is required to find the number of terms of this sequence. Since Tn equals a plus n minus 1 multiplied by d, since the last term is negative 133 and the first term of this sequence is 63, n minus 1 multiplied by the difference which equals negative 4. I'll transfer 63 to the left hand side to be negative 196 n minus 1 multiplied by negative 4 divided by negative 4. This is 49 equals n minus 1. I'll transfer negative 4 to the left hand side by dividing negative 196 divided by negative 4. Then n minus 1 equals 49. Then n equals 49 plus 1 equals 50. Therefore, T50 equals negative 133. Therefore, this sequence has 50 terms. The number of terms of this sequence equals 50 terms. Write down the first three terms of the sequence. Tn equals 2 plus 5n. Then find the order of the term whose value is 72, and find the order of the first term whose value is more than 100. Here it is required to write the first three terms of this sequence. Then if given a general term rule for the sequence, you can use it directly to find the terms of this sequence. I'll try to find firstly T1, which is the value of A. T1 equals 2 plus 5. I'll substitute by 1 instead of n. 5 times 1 plus 2 equals 7. Then T2 equals 2 plus 5 times 2 equals 12. Also, the third term of this sequence, I'll substitute by 3 instead of n, then it will be equals 17. If A equals 7, 12 and 17, then the difference of this sequence equals 12 minus 7 equals 5. Here, the difference of the sequence equals 5. This sequence is infinite sequence. It is unlimited sequence. It has infinite number of terms. Also, this sequence, its difference is a positive number. This sequence is an increasing sequence. Then, it is required to Find the order of the term whose value is 72. Then I can solve this question using two steps, two different methods. I'm sorry, I'll erase this part to write the solution of the second part. It was clearly that A equals 7, also the difference equals A equals 7, also the difference equals 5. Then find the order of the term whose value is 72. I can use the general term rule of this sequence directly. Here the term equals 72. 2 plus 5 multiplied by n. I'll transfer 2 to the left hand side. Therefore 70 equals 5n. Then I'll divide by 5. Therefore n equals 70 divided by 5 here equals 14. N equals 14. Therefore T14 equals 72. The order of the term 72 is the 14th term. Also, it is required to find the order of the first term whose value is more than 100. Before I'll answer the next part of this question, I can solve the part of the term 72 by using another method. Here Tn equals A plus n minus 1 multiplied by d. Then 72 equals 7 plus n minus 1 multiplied by the difference, which equals 5. I'll transfer 7 to the left hand side by subtracting 7. This is 65 equals n minus 1 multiplied by 5. I'll transfer 5 to the left hand side by dividing 65 by 5. Here 13 equals n minus 1. Then n equals 13 plus 1 equals 14. Therefore T14 equals 72. Find the order of the term whose value is more than 100. I'll erase this part. Since Tm is more than 100, A plus n minus 1 multiplied by d is more than 100. Therefore 7 plus n minus 1 multiplied by d, which equals 5, is more than 100. Then n minus 1 times 5 is more than 100 minus 7 equals 93. Therefore n minus 1 is greater than, I'll transfer 5 to the right hand side by dividing 93 by 5. Here 93 divide 5 equals 18.6. n is greater than 18.6 plus 1 equals 19.6. Here n is more than 19.6, therefore n equals 20. Therefore n equals 20. The first integer, which is more than 19.6, is 20. Therefore, T20 is the first term which is greater than 100. I can find the value of this term. I'll try to find the value of this term T20 equals A plus 19D. T20 7 plus 19 multiplied by 5. Here T20 equals 7 plus 19 times 5 equals 102. The first term, which is more than 100, is the 20th term, and its value equals 102. In any arithmetic sequence, take care of this part. In any arithmetic sequence, I can find a general term rule for this sequence. I can find a general term rule of this sequence. Here, I will take this sequence as an example. If I have an arithmetic sequence of A equals 7 and difference equals 5, and the first term is 7, the second term is 12, and the third term is, the first term is 7, the second one 12, the third term is 17, and so on. Then Tn equals A plus n minus 1 multiplied by D. Then Tn equals A, which equals 7, n minus 1, I leave it as n minus 1 as it is, and D equals 5. I'll try to simplify this expression. Then Tn equals 7 plus 5 times n, which equals 5n, and 5 times negative 1 equals negative 5. Here Tn equals 7 minus 5, which equals 2 plus 5n. For any arithmetic sequence, you can find a general term rule for this sequence by using this rule. Tn equals A plus n minus 1d. You can find a general term rule in its simplest form for this sequence. Another example. Find the arithmetic sequence with fifth term equals 21 and the 10th term equals 3 times the second term. Identifying the sequence, then the arithmetic sequence with fifth term equals 21. Here T5 equals 21. I'll separate this page to write completely the problem. T5 equals 21, then A plus 4D equals 21, and this is the first equation for this sequence. Its 10th term, T10 equals 3 times its second term, 3 times T2. Then A plus 9D equals 3 times A plus D. Then A plus 9D equals 3A plus 3D. I'll try to write this equation in the simplest form. Then I can transfer the left hand side terms to the right hand side. Then 3A plus 3D minus A minus 9D equal 0. Then 3A minus A is 2A. 3D minus 9D negative 6D equal 0. I write these two equations. A plus 4D equals 21. Also the second equation is 2A minus 6D equals 0. You can solve these two equations by using your calculator. For the steps mode equation, I'll choose number 1. Then I write the coefficient of each term in order of 1, mode, 5, 1. I write A, the coefficient of the term A equals 1, then 4, then 21, then 2, then negative 6, and the last term is 0. Then x equals 9, the calculator, by using calculator, A equals 9 and the last term and the D equals 3. In this sequence, the first term of the sequence is 9, then I'll add 3 in each step. This sequence is an increasing sequence because 3 is a positive term. 9, 12, 15, 18, and so on. Find another example in identifying. I write the title of this part, identifying the arithmetic sequence. This part is called identifying the arithmetic sequence. Find the arithmetic sequence whose sixth term equals 20 and the ratio between the fourth and the 10th term equals 4 to 7. It is required to find the sequence whose sixth term equals 20. Here, the sixth term T6 equals 20. Then the first equation, A plus 5D equals 20. Also, the ratio between the fourth and the 10th terms T4 to T7 equals 4 over 7. Then A plus 3D over A plus 6D equals 4 over 7. Then 7 multiplied by A plus 3D equals 4 multiplied by A plus 6D, then 7A plus 21D equals 4A plus 24D. Then 7A plus 21D minus 4A minus 24D equals 0. Then 3A minus 21 minus 24 equals 3D equals 0. This is the second equation. I'll try to solve these two equations, equation number 1 and equation number 2. I write them. A plus 5D equals 20. I use my calculator to find the solution set. 3 equals negative 3, mode equation number 1, and I write the coefficient of each term to find A equals there is something wrong in this equation, and the ratio between the fourth and the 10th term, I'm sorry, there is something wrong here. I'll erase T7 is it's a T10, which equals A plus 9D. Then 7 multiplied by A plus 3D equal 4 multiplied by A plus 9D. 7A plus 21D equals 4A plus 36D. 7A minus 4A plus 21 minus 36 equal 0. Then 3A minus 15D equals 0. This is the second equation. And This is the first one. 3 equals negative 15 equals 0 equals 1 equals 5 equals 20. Then A equals 10, also D equals 2. The first term of the sequence equals 10, and the second, and the difference of this sequence equals 2. Therefore, the sequence terms equals 10, and in each step I will add 2. The second term is 12, 14, and so on. In this lesson, we define the general term rule of the arithmetic sequence. Also, we know the steps of identifying the arithmetic sequence. Thank you. On the next session, we will discuss together the arithmetic mean. Thank you.